Hello students, this is Savitha from Marani Science College for Women. In this video, we will be learning Aldol condensation, its mechanism. So let us look what is an Aldol condensation. So when aldehydes and ketone having at least one alpha hydrogen are treated with dilute alkali which act as a catalyst, they form beta hydroxyaldehydes commonly called as aldol or beta hydroxyketone which are called as ketone. This reaction is known as aldol condensation. So, Aldol condensation is a reaction in which two molecules of aldehyde, one of them containing an alpha hydrogen, undergo self-addition in the presence of base to form a product called as aldol. This reaction is called as aldol condensation reaction. So let us take the example of an aldehyde, acetaldehyde. So as I said, one of the aldehydes should have an alpha hydrogen atom, which is a condition for the aldol condensation. Two molecules of acetaldehyde undergo self-addition in presence of the NaOH, which is acting as a catalyst to give the product, and the product here obtained is an aldol which is 3-hydroxybutanol. So this product upon heating results in an unsaturated aldehyde, and here the aldehyde or unsaturated aldehyde is crotonaldehyde. Similar type of the reaction also occurs with the ketone. For example, two molecules of acetone in presence of dilute NaOH give the diacetone alcohol. Upon heating results in an unsaturated mixed oxide. And as I said, for an aldol condensation, presence of alpha hydrogen is an essential. For example, the formaldehyde does not contain an alpha hydrogen. The same is also true with the aromatic aldehyde. The benzaldehyde does not have an alpha hydrogen, and hence no aldol condensation occurs between two molecules of formaldehyde or between two molecules of benzaldehyde. So in detail, when two molecules of acetaldehyde in presence of dilute NaOH results in the aldol product, which upon heating results in an unsaturated, and this unsaturated aldehyde is often referred as aldol condensation product. The characteristic feature of this reaction is the product that is formed is a larger molecule and contain a newly formed carbon-carbon bond. The newly formed carbon-carbon bond occurs between the alpha carbon of one aldehyde and molecule that was originally the carbonyl carbon of the second aldehyde molecule. The product that is obtained have two functional group. One is aldehyde and another is hydroxyl group. The hydroxyl group is always attached to the beta carbon, which is two carbon atoms away from the functional group. This aldol product can undergo easily dehydration, that is the minus H2O, to produce the alpha beta unsaturated aldehyde, and the product here is butenol. So when we take an example of a ketone 2-propanol in presence of the base barium hydroxide result in the condensation product. Since we have taken the ketone, here we name it as ketol, and the product that is obtained is 4-hydroxy 4-methyl penta 2-one This upon dehydration, that is removal of water molecule, results in the 4-methyl pent 3 2 on, which is an aldol condensation product. So the aldol compound have two functional group. The one is carbonyl group and another is hydroxide group, and hence the name for the resulting compound is aldol compounds which having two functional group. Coming to the mechanism of aldol condensation, the mechanism occurs in 3 steps and the dehydration is the last step. Aldol condensation is an organic reaction in which an enolate ion reacts with the second molecule of carbonyl compound to form the beta hydroxyaldehyde. Hydroxide ion function as a base, therefore moves the acidic of alpha hydrogen, producing the reactive enolate ion. This reaction can be seen as an acid-base reaction. The aldehyde is attacked at the electrophilic carbon carbonyl carbon by the nucleophilic enolate ion. This attack is a nucleophilic addition reaction and given an ellipsoid intermediate. The ellipsoid intermediate deprotonates the water molecule or a proton is added to this intermediate, resulting in the formation of beta hydroxyaldehyde. Let us look the mechanism of aldol condensation. As I said, the mechanism involves 4 steps. The first step is the removal of alpha hydrogen, result in the formation of carbanion. The hydroxide ion, which is formed from the base, deprotonates, that is, it removes an alpha hydrogen from the first aldehyde to give the carbanion. This carbanion gets stabilized by the resonance phenomena. So this is the first step, the removal of alpha hydrogen, formation of carbanion. The second step is the nucleophilic addition reaction. Here the enolate ion or the carbanion that has been formed in the first step attacks the second molecule of the second aldehyde molecule, and this undergo nucleophilic addition with the carbonyl group of the second molecule of the aldehyde, resulting in the formation of a alkoxide ion, and this is a condensation product, that is the alkoxide ion. And the third step is the protonation of the alkoxide ion. Protonation of the alkoxide ion will occur due to the reaction of the alkoxide ion with the water molecule to give the corresponding beta hydroxyaldehyde. This upon dehydration, there is a removal of water molecule resulting in the formation of alpha beta unsaturated aldehyde, and hence the last step is the dehydrating of the product to form a alpha beta unsaturated aldehyde. Coming to the aldol condensation in ketonic compound, the aldol condensation is the same in the ketonic compound, only the reactivity comparatively with the aldehyde. In the case of ketone, it is less. That is, the reactivity towards the aldol condensation is less, and only a small amount of the product is formed when we use the acid-acid catalyst in the reaction. The aldol product that has been formed undergoes dehydration to form an unsaturated ketone. Let us look the steps involved in the aldol condensation in the case of the ketone. So the first step is the protonation or the protonation step. The protonation of the oxygen of the carbonyl group occur. The step 2 is the formation of enol. So here the water molecule behave as a base, will remove the acidic hydrogen, alpha hydrogen, resulting in the formation of enol. And the last step is the attack of protonated carbonyl group of a second ketone molecule, resulting in the formation of the aldol product. So this is all about the mechanism of aldol condensation in the case of the ketones. Coming to the next, the crossed aldol condensation. So as the name itself indicates, when the condensation reaction between two different molecules of aldehyde or a ketone occurs in presence of water or alcohol, this is referred as crossed aldol condensation. So the two different molecules of aldehyde or ketone, here the condition is one of the molecules, whether an aldehyde or a ketone, should have an alpha hydrogen atom. So here the reaction can occur between two aldehyde which have alpha hydrogen. In those cases, we get four different types of product. However, when the reaction occurs between two aldehyde and one of them does not contain an alpha hydrogen, then it results in the formation of only two products. So the another example for a crossed aldol condensation is the reaction of benzaldehyde with acetone. So the benzaldehyde molecule does not have an alpha hydrogen. It's going to react with an aldehyde having an alpha hydrogen. Since these are two different aldehyde, we call this type of aldol condensation to be the crossed aldol condensation. So this results in the formation of 4-hydroxy 4-phenyl to butanol. The same example here, the benzaldehyde reacting with acetaldehyde results in the formation of aldol product. Upon dehydration results in the crossed aldol, that is the cinnamaldehyde. So this is all about the crossed aldol condensation. Let us recap the mechanism of aldol condensation once again. So, an hydroxide ion removes a proton, that is the alpha hydrogen, from the aldehyde, resulting in the formation of carboanion. This carboanion attacks the second molecule, results in the nucleophilic addition, resulting in the formation of an intermediate. To this intermediate, a proton is added, that is, the protonation occurs, resulting in the formation of beta hydroxyaldehyde, which is an aldol, and this is called as aldol condensation, and this can further undergo dehydration, resulting in the formation of an unsaturated aldehyde, which is called aldol condensation product. This is all about the aldol condensation. Thank you.